Hello. Today we're going to be covering graphs of polynomial functions and starting off with a graph of a polynomial function. The question is, when is a graph considered a polynomial function and when isn't it considered a polynomial function? Well, it's pretty straightforward. The first condition, actually there's two cases. You just need to look at whether it has any sharp edges. Looking at the first graph, do I have any sharp edges going on? Not really, right? I have this curve, which is smooth. It's not sharp. Sharp, I mean it's pointy, like if you touch it, it hurts. And this case, we don't have any sharp edges. This one is smooth as well. So that means the first condition works. We have smooth edges, which is totally fine. And do I have any jumps? No, which means this graph is continuous, right? And a continuous function is also a polynomial function. So you just need to look at whether the polynomial function is continuous and just make sure you don't have any sharp edges. Let's look at the second function. Well, I don't see any sharp edges, so that's fine. But this graph is not continuous. You can see a gap going on, right? There's a jump. So this function is not a polynomial function. That's it. Okay, let's test our knowledge with these four graphs. You can pause the video, try and solve this. Assuming you pause the video, you solve this starting with the first one, function f. It is continuous, which is good. It doesn't have any sharp edges, which is perfect. So it is a polynomial function. This one has a sharp edge, so it's not a polynomial function. With h, we do not have any sharp edges, and it is continuous, which is a polynomial function. What about k? There's a gap going on. It's not continuous. It's not a polynomial function. That's it. Pretty straightforward. Now this is the most important part of the video. So I do suggest you pay attention. You watch this at 1 time. Don't do 2 times. Let me just erase all of this for a second. You don't need to focus on any of this. Just focus on what I'm going to explain, which is factoring basically. So let's say I have f of x, which equals to x squared plus, let's say 4x plus 3. And I want to factorize this. Now, if you're good with factorization, just by looking at this, you can tell that it's x plus 1 multiplied by x plus 3. Now, if you don't know this, that is totally fine. How do we find the factors? We've taken this before. We simply just do x1 equals negative b plus or minus b squared minus 4ac, right? Divided by 2a. So we do 2 cases. x1 would be the positive version, right? And x2 is simply the negative value of x1, which would be negative b minus b squared minus 4ac divided by 2a. Okay, pretty straightforward if you want to find x1 and x2. But the thing is, let me just erase this. Let's go back to x squared plus 4x plus 3. Now, if I do b squared minus 4ac, just b squared minus 4ac, what does this tell us? I'm pretty sure you should know. If it's greater than 0, it means we have 2 solutions, right? Do you remember this? And if it's equal to 0, we have one solution, and if it's less than 0, it means we have no real solutions, right? Now in this case, if I take, so it's ax squared, remember, plus bx plus c. If I take b, which is 4, and I square it, and then I subtract a minus 4ac, which is negative 4, multiplied by 1, multiplied by c, which is 3, what do I get in this case? I'm simply left with 16 minus 12, which equals to 4, which is greater than 0, which means I have two solutions, which is what we got, right? We got two solutions, x plus 1 multiplied by x plus 3. Now, if it was equal to 0, you would only get one solution. Let me give you a quick example on that. Let's say I have x squared plus 2x plus 1. If I do b squared minus 4ac, in this case, what do I get? I get 2 squared is 4 multiplied by 1 multiplied by c, which is 1. So this is 4 minus 4, which equals to 0, which basically means I'm dealing with one solution. Now, what is this one solution? Well, it's simply x plus 1 squared. That's it. Now, what if I have, let's say, x squared minus x plus 3? What is b squared minus 4ac? What's going to be negative 1 squared minus 4 multiplied by 1 multiplied by 3, which is simply 1 minus 12, which is negative 11. And what does this tell us? It tells us that it has no real solutions. But what we're going to do is we're going to simply find the complex solutions, which are the complex numbers. In this case, we have x1, which equals to negative, remember, negative b plus square root b squared minus 4ac divided by 2a. Now, x1 equals to, what is negative b? It's simply negative of negative 1, which is 1, plus, what is b squared minus 4ac? It's negative 11, divided by 2, multiplied by 1, correct? So x1 equals to 1 plus, what is square root negative 11? It's square root 11 multiplied by square root negative 1, right? Divided by 2. Now always remember that I, which is the imaginary number, it equals to negative square root of negative 1, I'm sorry. So x1 equals to 1 plus, instead of writing square root negative 1, I'm going to write square root 11 multiplied by I, and this is divided by 2, and this is divided by 2. So this is your first x1. How do I find x2? Well, it's very simple. You don't need to do all of this. Just write down 1/2. Instead of writing this plus sign, what do? I write down a negative square root 11 divided by 2i, and that is it. All good? So what do I take from this? What I take from this is that on the test, or whenever you're solving no real solutions, let's say I tell you that we have x, which is a factor, and I tell you I have x minus 3 plus I, which is a factor, and there's a third factor going on. What is the third factor? Well, the first step is to write down x minus, right? Because you always change the sign when you're plugging in the solution. Now, since 3 plus I is a solution, let's change colors. Look at x1. It was 1/2 plus square root 11i divided by 2, which is the first solution, right? How do I find the second? You just change the sign. If I know that 3 plus I is a solution, I change the sign of the imaginary number, so it's going to be 3 minus I, which is the second solution. Okay, so these always come in pairs. They're besties. You just change these signs and that's it. And yeah, that's pretty much it. So let's move on to example 4. Let me just erase this. Okay, there we go. And your best friend is b squared minus 4ac. And if you want to factor, as I've mentioned, you don't need to take out monomial factors, binomial or trinomial factors. You could just, as I've mentioned, do b squared minus 4ac, do the quadratic formula. But what they're telling you with trinomials is that, let's say we have x cubed plus, let's say, x squared, let's go with 2x squared plus x. What you can do is you can take x as a common factor. You open parentheses, you're left now with x squared plus 2x plus 1, right? Now this, remember, we just did it, right? And x, so it would be like x multiplied by x plus 1 squared. Now this rarely shows up, but if it does show up, you just take x as a common factor, then you just bother yourself with the quadratic function, and yeah. Okay, let's erase this. And we all know how to find y and x intercepts. What does y-intercept mean? It means that x equals to 0, you plug this in, you find y, right? So y equals to 0 minus 2 squared, 2 times 0 plus 3, you got 4, you got 3, you got 12, right? Now, I'm not sure if I made a mistake, but I'm pretty sure you understand this. Now, how do I find the x-intercept? You plug in y equal to 0, and then you take out the factors, you find the x-intercepts. So if this equals to 0, what do I have? Let me just write it down. So I have x minus 2 squared, 2x plus 3 equals to 0. You take every single factor, taking the first one, you place it equal to 0, you get x equal to 2. You take the second, you place it equal to 0, you get 2x equals to negative 3, x equals negative 3 divided by 2. That's it. All good? These are the two x-intercepts. Let's erase this. Moving on to this one. We have this function, and the question is that notice in figure 7, well, I'm assuming this is figure 7, that the behavior of the function at each of the x-intercepts is different. Okay, now this is really important. This is the second most important part of this video. Actually, all of this video is useful, so actually watch it at a slow pace. Anyways, by looking at this graph, what are the x-intercepts? Let's just first understand what are the x-intercepts. We have negative 3. We do have negative 1. We all have 2. And all of them react differently at every single x-intercept. So the function is behaving, I would say, it has a different behavior at every single x-intercept. And so yeah, it behaves differently at every single x-intercept. Starting with the first one, it's passing through negative 3, right? And this is the one this is the common one. And if it's crossing through negative 3, you write it as x minus, you write the value, which is negative 3, then you close the parentheses, it's x plus 3, right? This is the first x-intercept. Now, let's jump to 2, then we can come back to negative 1. With 2, it's bouncing off, right? You see how it's bouncing off? Since it's bouncing off, well, first it's 2, so you open parentheses, you do x minus, you write down 2, so it's x minus 2, right? Well, since it's bouncing off the x intercept, this parentheses will be squared. That's it. That's the difference between the first one and the second. So one is squared and the other is not. And it's called multiplicity. So how many times this is multiplied? Multiplicity comes from the word multiplied, right? So x plus 3 has a multiplicity of 1 because it's only multiplied by itself one time. What about x minus 2 squared? Well, this is x minus 2 multiplied by x minus 2. Now, what about negative 1? Well, you can tell that it's crossing the x-axis and actually, you could say like moving on the x-axis, right? Has this odd shape where it's moving on the x-axis, then it's moving, going its direction, whether it's up, above, or below the x-axis. And in this case, since it's on the x-axis, it's moving on the x-axis, what happens? Well, you open parentheses, you do the exact same thing. First, you do x minus, you write down the x value, you open parentheses, negative 1, it's x plus 1, right? Now, this has a multiplicity of 3. And these are the only 3 conditions that you're going to see on the test, 1, 2, and 3. That's it. Okay, I'm recording. Can you please, yes. So, yeah, I'm sorry about that. Let's move on to this one. Okay, so this has a single 0. It crosses. This has a multiplicity of 2, as you can tell. And this has a multiplicity of 3. Pretty simple, pretty straightforward. Now, what about this? Well, the graphical behavior of polynomials at x-intercepts. If a polynomial contains a factor of the form, the behavior near the x-intercept h is determined by the power p. We say that x equals to h is a 0 of multiplicity p. Yeah, so this is basically the 0, and the multiplicity would be p. And the graph of a polynomial function will touch the x-axis at zeros with even multiplicities. And the graph will cross the x-axis at zeros with odd multiplicities. The sum of the multiplicities is the degree of the polynomial function. Now, you may say, what does it mean for it to touch, and what does it mean for it to cross? Well, let's look at this. P equal to 1. Is this odd or even? It's odd, right? And, well, the function was below the x-axis. Now it's above the x-axis after going through 1. Now let's look at p equal to 3. Well, the function was below. Now it's above after p equal to 3. Doesn't matter how it behaves. Well, with p equal to 3, you can tell it moves on the x-axis. Now with p equal to 1, it just crosses the x-axis. With both functions, well, you can say it crosses. Yeah, with both functions, the graph is crossing the x-axis. Well, they're just behaving, or they just have different behaviors at those x-intercepts. Now, what about the even multiplicities? They just bounce off or touch the x-axis. Okay, given a graph of a polynomial function of degree n, identify the zeros and their multiplicities. This is very simple. Well, it's not very simple, we just took it. So if it's linear, if it's crossing and it appears almost linear, as you can tell, it's almost linear. It's going to be a single zero, like one single zero. And if it touches, it bounces, it's a zero with even multiplicity. And if it crosses the x-axis at a zero, it is a zero with odd multiplicity. The sum of the multiplicities is n. Now, some books, others don't refer to this. Some say crossing means like crossing as in crossing. Odd multiplicity would mean like, let's say 3 and above. Others would refer to 1 and above. And you don't need to bother yourself with that. You just need to understand this. Recording for you guys. Why don't you finish?
I just wanted to tell you, one of the videos isn't working. Can you try to make it public instead of...
Which one?
I think part 2.
Okay.
Thank you.
Okay, so do this. Do it on your own. Actually, no. We'll do this one together. You do this on your own. So for this one, it's bouncing off -3. It's passing through -1. You want to call this cross? It's crossing through 4. So if it's bouncing off -3, well, the first step is you do x minus, right? You open parentheses. It doesn't matter whether it bounces, it crosses, it touches, whatever it is. You always write down x minus. Now -3, you write that down as well. You do the parentheses, you don't forget that. And since it's touching, you do squared, so it's x plus 3 squared. Now what about -1? It's passing through -1, so x minus -1 is simply x plus 1. You could tell it's linear at -1. Now with 4, it's x minus 4. And this is simply the shape of the multiplicity of 3, right? So it's x minus 4 cubed. That's it. You have this, you have this, and you have this. You write them next to each other, so it's x plus 1, x plus 3 squared, and x minus 4 cubed. And you should write a in front of them because we don't know whether this is like 2x plus 1 or whether it's like 3. It could be negative. I don't know. But how do I know? You solve it by plugging in a number. You can take this number, let's say. When x equals to 0, y equals to negative... am I smart enough? From -80 to... Okay, so this is like what, -120? It is, yeah. So this is -120. So when x equals to 0, you plug this in. You plug in 0. You take -120. You place this equal to -120. And then you find a. If you don't know how to solve this, you can ask me later, okay? But this is how you solve a. You plug in 0 for x. You do the math. You find a. That's it. Okay. Now what I want from you is to solve this one and try and solve a as well. Which point do you take to solve a? When x equals to 0, y equals to 10. You take this, you take this, you take this. I'm not going to help you, okay? You do this. You do this on your own. I'm not going to explain this. Why? Because I explained it through the powers function. I don't remember whether it was through 1 or 2, part 1 or part 2. But if you don't understand this table, have a look at it. If you don't understand it right now, go back to the powers functions video, which is, I'm not sure if it's 1 or 2. And what about this? Well, I did explain this through the powers function video as well, turning points. This is a turning point, this is a turning point. I'm not gonna explain this anymore. If you don't understand this, go back to the powers function video as well, okay? Same with this. If you don't understand this, well, I'm sorry to tell you this, but you have to go back to the powers function. Oops, what about this question? Same exact story. I'm not going to explain it. You have to go back to the powers function. But what I am going to explain is this, which is how we understand is functions that are even and odd functions. So an even function is f of negative x, which equals to f of x. This would be considered an even function. An odd function is where f of negative x equals to negative f of x. Now, let me give you an example on every single... There's only two cases, I'm sorry. So let's take an even function. What's an even function? Well, it has an even degree, right? That's why it's called an even function. Now, when I say even degree, I'm looking at the highest degree of that function. If you watch the powers function, it means you understand what I'm talking about, right? You take the highest degree, and that would determine whether your function is even or odd. So if I write down x squared, well, this is an even function, so this means that f of negative x must equal to f of x. Is that true? F of negative x equals negative x squared, which is x squared, and f of x is x squared, which is x squared. They're equivalent, so this is true. Now let me take an odd function, and let's prove f of negative x equals negative f of x. X cubed, right? What is x cubed? What is f of negative x? Well, it's simply negative x cubed, which is negative x cubed. What is negative f of x? Well, it's going to be simply negative of x. Well, it's just x cubed, right? So it's just negative x cubed, and they are equivalent, which means that is also true. Now, what about the intermediate value theorem, which is the theorem right in front of you? This doesn't show up much on the test, but it is good to know it. It's fine. Knowledge is knowledge at the end of the day. So, yeah, what about it? So if I have f of a, which is negative, and f of b, which is positive, it doesn't matter which is negative or which is positive. As long as these two have opposite signs, it means that there will be a point which is an x-intercept between these two points. At least one. There could be more, but at least one between a and b for which f of c equals to 0, which means that c is an x-intercept, right? And that's it. It could be the other way around. It doesn't have to be like this. It could be like this. Let me show you. It could be, let's say, like this. So this could be f of a, which is positive. So let's write it as positive. And this could be f of b, which is simply negative. And this is f of c, which is a point between. Okay? Now, last but not least, I want you to write a formula for the following polynomial function as well. You deal with this point, you deal with this point, you deal with this, and that is it for this video.